So I turned mine off. I turned mine off this morning.
If it's yours, there's only 40 questions.
Can you agree to that?
No, it's off. It's off. It's airplane mode, not me. What?
Are there going to be
I don't know.
It's not me. No one
Can't tell you.
else.
So if I'm looking at something like this, and I need to figure out which equation it is, the easiest thing to decipher is what direction it's opening. If you know what direction it's opening, obviously they're telling you that it's an x squared parabola, which means it's either going to open up or it's going to open down. So what I do is plot it and then figure it from there. So my vertex is at 7 and negative 8. And my focus is at negative 97 over 12. Is negative 97 over 12 is 8 and change, isn't it? Which means it's further away. What direction is this opening? Downward. So just by doing that, I know it's got to be either one of these two. Because they're negative. Now, not knowing how to do anything about math, I'm thinking about my standard form of the equation for a parabola with an x squared portion. Now, if you recall, that meant it was x minus h quantity squared equals 4p y minus k. Now, in this case, what they have is another format of that. Bless you. Thank you. But if I know this is certain, which one does it have to be? It has to be B. And why is that? Because the K value, or sorry, the H value is 7, so it's got to be x minus 7. No matter what, I don't have to do anything else. I can, if I want to, go through and figure out what my P value is. I know that my distance from my center, or excuse me, my vertex to my focus is the value of P. In this case, it is 1/12. All right. My P value is 1/12. Which means the 4p becomes, what is that? I know it's moving downwards, so it's got to be negative. So the equation would be x minus 7, quantity squared, equals negative 1/3 y plus 8. Well, how are they getting this as y equals? They're multiplying by negative 3. And then they subtract the 8. And then there's y. That's how they're getting that value of a constant without the fractional amount of the p. Okay? That's what that works. But you didn't need to remember any of that. All you had to remember was, okay, it's got to look like this. It's opening downward. It has to be a negative value for the A. Which one of those gives me the correct H? Go to the next problem. Start.
And then all the failed are drafted on the
Correct. Yeah. Absolutely. Okay. That would have worked as well. All right. It works the exact same way if you're looking at 83. You do basically the, yes sir?
How did you know it was opening down?
The negative 97 over 12 is negative 8 and a 12th. Negative 8 and a 12th is smaller than negative 8. So it's moving downward. Your vertex always opens to the focus. Okay.
Oh, okay.
All right. All right.
How did you know that I had a negative 3?
The only thing that I had to worry about in this case here is that we knew it was opening downward, so we knew it had to be a negative.
Oh, okay.
How I got it to be negative is that I knew that my distance from vertex to focus was 1/12, but it was moving downwards, so it was negative 1/12. I put that back into here, so it's 4p, so it's 4 times the negative 1/12, which gave me the negative 1/3, which gives me the 3 when you multiply it.
Oh, okay. So it's not like you just did some like physics and like math thing, and then like you're like, oh, this has to be this. Without
No.
even doing anything?
No, you only,
Okay.
to be honest with you, the only thing you have to know in this problem, what direction did it go and how do you find H?
Okay.
That's it.
Did you put a negative in the head?
It just got moved over.
Because like for the next one,
Same thing.
so we could look at the last guy.
It does work. We don't show it like that, but it does work.
For everyone.
It works because you multiply by the reciprocal prior to distributing.
So the one
What's up? Distance from vertex to focus. Center and radius. If I do center and radius, I'm going to look at 84 because it's more work than 85. In order to make this one work, we have to put it in the generic format for a circle. Now a circle is x minus h quantity squared plus y minus k quantity squared equals r squared. Okay. Which means I have to complete the square. Well, when I complete the square, I want my first terms to be positive. So what I'm going to do is add all of this to that side, and then add 74 to that side. Basically, I'm multiplying the entire equation by -1. Yes, sir.
So all of these formulas are already in the calculator?
Yeah. Hit X. X. So it's setting me up to have to complete the square. When you're completing the square, rewrite in group. You have x squared minus 10x plus blank plus y squared plus 2y plus blank equals 74 plus blank plus blank. Okay? What's half of negative 10?
-5.
Square it.
25.
Add 25 to both sides. Half of 2. Square it. So we have x minus 5 quantity squared, y plus 1 quantity squared is 100. Center is located at 5, -1 with a radius of 10. The next problem.
Whoa.
Sometimes you might surprise yourself and remember a lot more than you thought.
No, I don't remember these.
Yeah.
86 just looks ugly
Yeah.
because you have to do a lot of completing the square. When you're completing the square to identify the center, vertex, focus, all that kind of junk, we have to first of all put it in the generic form of the conic. Group them out, 121 x squared, 242 x, 16y squared minus 320y is 215. First rule of completing the square is to take out the leading term coefficients. Take out the 121. Bless you. Take out the 16. Add them in on the other side. What's half of 2? Square it. What's half of -20? Square it. Uh, 1600 plus 3. What is it? 16. So it'd be 936.
Yeah.
Wouldn't it be convenient if you divided it all out and you get 121 and 16?
Yeah.
Is that what happens?
Yeah. Yeah.
Is it?
Yes. No.
Yeah.
So it's an ellipse, but what direction is it being stretched if the a squared is underneath the y value? Look at the program in your app. I believe it's up and down. I think it's up and down, right? There you go. It's stretched up and down because the picture tells me so. Right? Yes, sir.
So if we don't have that function,
I can, yeah. I can add it, or what I might do is just print out that little sheet with it on there to have it. Maybe. Okay. So now I know that my a squared value is 121. My b squared value is 16. How do you find c squared with an ellipse? Well, what's between? It's minus. Remember, it's always the opposite sign of whatever the generic equation is.
right.
Ellipses have the plus sign between the two. Hyperbolas have the subtraction. Therefore, it's opposite signs for the a squared and b squared. Okay. So I know that my center is going to be located at -1 and 10. Yo,
Having said that, which side is a squared and which side is b squared?
which one? In an ellipse, remember the a squared is the bigger of the two.
Okay.
When it's a hyperbola, the a squared is just first. Then it's x or y comes first. So your a squared, 121. B squared, 16. C squared is going to be 105.
Yeah.
So that means that my a value will be plus or minus 11, b value is plus or minus 4, and c value will be plus or minus the square root of 105. Now it comes into the quick idea of what do I have to add and subtract to figure out the vertices and the co-vertices. When you have the vertex, we know that it's being stretched up and down. When you stretch up and down, what doesn't change? The x value. The x value won't change because it's got to be vertical. So all you have to do to figure out, excuse me, we're going to add and subtract the 11. We add and subtract the 4. Yes, sir.
How do we find the c value?
It's a squared minus b squared to get c squared for ellipse.
Wait, so A and B decide the difference in what the distance between.
A is the distance from your center to your vertex. B is the co-vertex. C is always the focus. And that's how you just add them and subtract them from the center. Okay.
Isn't that the distance of the 105 then?
The square root 105, yeah. So you'd be going up and down 105, root 105 from, what's our cave?
Or not,
What's that, -1? Center is at -1 and 10. So you move up and down from there. They'll be vertical from another. Excuse me. The other one that was on here that people have been asking about is forgetting how do you write the equation given information. For example, if I'm at 88, and I need to write the equation into standard form, and I think it told you that it was an ellipse to start with.
Yeah.
Okay. Each ellipse. That's always good to know. So notice what's not changing for the vertice and the foci. The x value. So that means it's got to be stretched up and down.
Yep.
Okay. So I know that it has to be stretched up and down, and it's at -9. And, well, look what happens here. It's 5 plus something, it's 5 minus something. It's 5 plus something, it's 5 minus something. Where's the h and the k?
And 5.
So we get -9 and 5. So I know that my center is going to be at -9 and 5. It has to be. Just by looking at that. Now I know that the generic form, x minus h quantity squared over whatever, y minus k quantity squared equals 1. We know, everybody's okay, that's got to be stretched vertically, correct? So that means that the larger of the two numbers is going to go here. And I already know bits of information. X plus 9. Y minus 5. Now, without having to do too much other math, I'd start looking at my possibles for my answer key. Because if I have these two as my h and k already, I might be able to pick out 2 out of the 4 that could be possibilities. Then within those 2, is one of them have the larger number under here or here? What I'm getting at is that a lot of times in these conic questions, you don't have to go through the entire process to get to the solution. You might be able to say, hey, I know that the bigger of the two numbers has to be here. All right? I know it has to be. Now, the distance would be 5 root 5 and 3 root 10. I know that the a value is the distance from the center to the vertex. Well, what's 5 root 5 quantity squared? What's 5 squared? What's 25 times 5? 125. So my a value a squared has to be 125. I do the same thing with the 3 root 10. Well, 3 root 10 isn't going to get me my b value, is it? No, but by doing that a value, I've also picked out another possibility of my multiple choice questions without having to go too much further. You might be able to pick out, hey, only one of them has 125 for an a squared. You see what I'm getting at, you guys? A lot of it doesn't have to go into as much depth of writing out the entire format as to what I was having you do when you did it longhand, because it's multiple choice. There's got to be there's going to be a spot at which you should be able to realize what the answer is without having to solve the problem. And that's hopeful. Hopefully, I should say. Yes, sir. I like your glasses. Those are nice.
How do you know that 125 goes under?
Do you agree that we understand it's got to be stretched? The a squared would be the distance then from the center to the vertex. Because notice how the x value doesn't change for anyone? Is your vertice always overscope focus? Since they're above one another. Now, I could go further and figure out what b squared is if I'm not sure off the top of my head. I know that the c squared is going to be 9 times 10. Okay with that? So my c squared is 90. A squared is 125. So b squared has to be, well, 125 minus something is 90. 35. And by then, you should be able to get the right answer. A lot of these you're going to be able to figure out without doing all of them. That's what we're trying to get at with comics. I know a lot of you guys were worried. But if you know just enough to be dangerous, you should be okay.
Dangerous mind.
Don't ever do that again. Hyperbola. I have a hyperbola. If those are my two vertices, what direction is it going? Up and down. Has to be. Has to be going up and down because they're vertical of one another. It has to do this. Ooh, wow. It has to do something like that. What occurs halfway between vertices? The center. I know that the x-coordinate of the center has to be, dun dun dun, 1. So what's 21 plus negative 5? What's happening? 8. So I know that the center has to be at 1. and 8. Because my distance from here to here is my A value. It's okay. Hey, Chimkey, earlier I did this whole problem earlier today with a positive 12 and it was awful. It's okay, we miss signs all the time. They're right in front of you, you just miss them. That was the analogy.
Oh, why not, why isn't it 21 plus 5? Because you have negative 5 on this side of the equation, but 21 on that side of the equation. So shouldn't it be 26?
Midpoint.
Yeah.
Think of midpoint. Midpoint, you add your x, you're taking the average of the x, average of the y's. How far apart is 8 and negative 5? 13. How far apart is 21 and 8? 13. Their distances are the same apart. Okay. That means my A value is 13. Should be what?
Yeah, that's what I, yeah, I think this.
What's 7?
What's?
All right. 21 plus negative 5 is 16. What's half of that? So that's where it is.
But it's at 1.
Midpoint.
Yeah, midpoint is at 1.
Can you give me some?
No, thank you. The X is at 1.
The x is at 1. What's 1 plus 1?
1.
They have to be on the same line. No. At 1 and 8. The reason that it's on 1 is because the x coordinate didn't change. That means I knew it was a vertical ellipse, or ellipse, excuse me, hyperbola. Oh, so we know that the value of A is 13. Since the hyperbola is going up and down, we look at it and say, hey, according to my calculator, my hyperbola equations that are up and down have the y value come first. So I know it's got to be a y minus 8 quantity squared over a squared, which is 169, minus x minus 1 quantity squared over whatever our b value is. We know that our c value is the square root of 269. That means my c squared value, if c is root 269, c squared is 269. Our a squared was 169. So what's b squared? No. Well, it's 100. Because remember, since this is a subtraction, a squared plus b squared is c squared.
Yay.
That's how that one spools itself through. You start with the idea of where is it being located, what direction is it going, and then just using the little bits of information to solve it out. Okay? Classifying conics is actually a little bit easier than that. And I think we did these, didn't we? Did we do any of those? All right, well, let's do 97 real quick. If I need to figure out what kind of a conic this is, I need to get it into a standard form. One of the things you might notice right away is that you have that. Therefore, what should it wind up being in the long run? Ellipse. Should be a hyperbola because it's got the minus sign, okay? Has to be. So if I'm looking at a multiple choice test, I'm already going to throw out anything that isn't a hyperbola because I know it should wind up there. So I group them. Also, notice that what's your K value going to be in this case? It's going to be 0. Okay? It's going to be 0 because there's no Y value. So right there, I can be looking at it, looking for a hyperbola that just has Y squared, no Y minus K quantity squared. So I can probably be done with the problem just by getting this far. But if not, I have to complete the square. Take out the 25. 6. Half of 6 is 3 squared is 9. 9 quarters is how much? Well, 8 quarters is how much? $2. So 9 quarters would be
$3.
And then you'd be able to do that real quick by dividing out by 25. Okay? Are you all excited for that problem there? Oh, you finally figured. Anytime I see quarters, I'm like, I start thinking of money.
You leave that up for a second.
Better yet? Oh no, how do I solve a system of equations with these things? I'm so frightened. Yes, sir. Yeah, seriously guys, there's no reason to go through the whole process of trying to do elimination with anything like this. That's why I threw these on here. I threw them on here just to remind you that one of these has to work. Okay? One of those has to work.
Is that one of R and one of A?
I don't know. Well, I'm just saying, one of all of those has to work. So all I'm going to do is just direct substitution and see if it works. If I substituted 0 for x and 5 for y, do I get 0 at the end? Does it work with 4 and -10? Does it work with -7 and 8? Does it work with negative? The only thing that I would say that you have to do is when you're squaring stuff that has a negative, what are you going to put around the negatives? Parentheses. Seriously, you could go through and do system of equations and solve all this stuff out. Obviously, you could eliminate the y values here by adding them together. Or sorry, subtracting them together. You can do that and it will work. You will get a factorable item. But why? Plug and chug. Yeah.
So for like the first test, you do that to the first equation, and then the second one, you do that to the second equation, or do you do them both to one equation?
One equation.
Okay.
You do each one of them.
Wait.
Because what you're looking at here is, I believe these are both ellipses. I'm sorry, hyperbolas.
Okay.
So you're looking at the possible intersection points of two hyperbolas and whatnot. So you could get multiple intersection points depending on where they lie.
Okay, so then you would do like, for the first one, you do 7x, 0, and then like you would go on.
I'd have to try this one here. I'd have to try this one here.
Okay.
So I basically plug and chug
Okay.
in
4 times.
4 times, or the other one I have to do it 6 times.
Okay.
That's all it is. Yes, ma'am.
Couldn't you put it in your calculator and like y equals, and then you just like look at the table?
Well, here's the problem. If I do that, I can't because I've got y squared and x's. Okay. So if you go the long form, if you took these, if I did the long form and not knowing what to do, and subtract everything out, so I have same variable, same exponent, same variable, same coefficient, same exponent, I get x squared plus 7x, 0. What are my zeros? Well, I have a 0 and a -7. Those are my two possible x values. So if I go back and look, Where do I have 0 and a -7? Well,
No second.
the second one.
What did you just do to get rid of that?
It's elimination. What I'm saying is if you forget, you can always revert back. Sir?
So if you're playing chunks, you just both all the points on each
Yep.
option have to fit in both sides.
Yep.
Okay.
Okay. It's just one of the methods. Elimination works. Same thing with the other one. If you look at 99, it's the same basic principle.
Honestly, that just scared the crap out of me.
Yeah, that
Sorry.
scared me a lot. That like made my chest like.
Yeah.
If I do the same basic idea, everybody see how I've got the opposite signs on the y squared with the same coefficient, opposite signs on the y values with the same coefficient? If I add these two together, I'll eliminate the y squared and the y. I get 24x squared plus 96x minus 120. And then I can just factor that. Take out the 24. I get x squared plus 4x minus 5. I'm setting that equal to 0. If I set that equal to 0, then I get x plus 5, x minus 1. So I have 0s, -5, and 1. So I have two possible x values, one at -5. Oops, I cut off that problem, sorry. One will be at -5, one will be at +1, so it's got to be B. Elimination method works just as well. Did that thing have an x value to it though? No.
No.
Since it was a constant, I'm just dividing out the constant goes away. Another thing that comes into play quite often with the, yes sir?
With 98, you eliminated and you had like x squared plus 7x, right?
In 98, I subtracted everything. By subtracting everything, -7 minus -7 goes away. -70 minus 70 goes away. That's what I was doing.
Okay, so then you're left with x.
I was left with x squared. Yeah.
And then you just have to get the zeros. And that. Okay.
Now, the other thing that's come up a little bit about what to do with zeros and whatnot, if you go back a little bit earlier with the polynomial stuff, somewhere in here. For example, number 35. If you had to find all possible zeros, and you knew that you had the equation to start out with, obviously, your starting point would be to list all your possible factors in the tail. It's plus minus divided by all the factors of the leading term. Now, normally I'd have to go through all my possible values to get at one of them to work with. I think we might have said, in this case, since you have your calculators, if you put that function into the y equals table, you'll be able to figure out where if one of them is an integer value that works cleanly, you'll see a 0 in the table for -1 or -5. One of these is going to have a 0 somewhere. That's what you utilize to start your synthetic division. It's a fast way to do it. Okay. I think I had that saved in my calculator earlier. Yeah, I already had that one in there. So if I go right to my table, and you'll see that I have a 0 at 5. Yeah. Yes, ma'am. I'll explain it in a second. Yeah, because whatever your degree is, you can have that many across the fifth grade. You have up to 5 zeros. That's all. Even if they have, even if they are imaginary. Yep. So this tells me that I have a 0 at 5, which means what I would do is use my synthetic division at 5. So I have 1, -5, -6, 30, -7, and 35. So it works. I have a 0.
What were you looking for in the table?
0 in the y column. That means you have a 0 for x. So this gives you x minus 5, and then you have x to the 4th minus 6x squared minus 7. And that's a factorable trinomial. You'll have an x squared minus 7, and then x squared plus 1. And what they're talking about, find all possible zeros across the complex roots. That means if it's a 5th degree polynomial, you can have a total of up to 5 zeros, including the imaginaries.
But it says there's 5.
Yeah, this complex, they all encompass.
Wait, so even if they're not imaginary, there's
Right.
complex.
When you say complex roots, it just means it's encompassing all.
Okay.
So here you have a 5 plus minus root 7 and plus minus 9. 5 roots. Okay. It's not like that one test where you guys come up with, when you were factoring stuff, you would give me like a 7th, I'd give you a 5th degree polynomial, you give me 7 roots. Those were the good old days. Yes, trying to find holes in the space-time continuum. Good times. All right.
Or better yet, you give us 5, and then they're all 5 of them are imaginary numbers.
Very easy to do that. Sure. There's the point. Simplify, okay? When you're simplifying roots, you have to get common radicals. Oops, that didn't work. So, square root of 18 is 3 root 2. So it's negative 2 times 3 times root 2. 45 is 3 root 5 and 3 root 5, so then you have plus 2 times 3 root 5 plus 2 times 3 root 5. So this is negative 6 root 2. What's 6 and 6? Go to the next problem. That's it. We'll try and do a bunch of the exponent problems tomorrow. Any leftover lingering things you come up with, I'll get you guys all those quizzes and everything back. I think there was one question you guys all screwed up on. It's just like my geometry class. Everybody got the same thing. What's 4x times 6x?
24x.
Just make sure you got the x squared.
General